Hello everyone, welcome to the video explanation for Brian Passwater's Topic 2-1 Notes, Example 5. Example 5 says several terms of the arithmetic sequence a sub n are shown above. Find an expression for a sub n, and then use that expression to find a sub 17. Okay, there are actually two different ways that we could approach this problem. And the reason is because we know more information than we normally know. If we look here, we have a sub 0 is 8. We have a y-intercept. There is a point on the y-axis, the a sub n axis, that tells us that initial value is 8. Then we have our first term is 6. Our second term is 4. Our third term is 2. We even have our fourth term is 0. Notice that in between terms, we are always subtracting 2. So this is just another way to display the same sort of information. They gave us way more information than we need to do this problem. So there are two different ways that we could approach this problem. The first way we could approach this problem is by using the slope-intercept version of the equation, because we know that the common difference is -2. That number is the same every time. That's that common difference. And we know the initial value is 8. So we could write this rule as a sub n is 8 minus 2n. That would work. The other way we could do it is we could use any of those terms as the kth term. It does not matter which one, so let's say we use the second one. We would plug that 4 in for a sub k, and then the term number 2 would go in for k. We would still plug -2 in for that common difference. So another option would be to have 4 minus 2 times n minus 2. Now these are really equivalent. These are the same exact rule. If you were to distribute the -2 and combine like terms, you would get 8 minus 2n. So it does not matter whether you use the initial term and the common difference, or any of those terms, 1, 2, 3, or 4, as the kth term, and write out the point slope-ish version. It doesn't matter. What matters is that we have an expression for a sub n. Either one of these would be an acceptable answer for a sub n, as would any other version where you use any of the other points as a sub k. So either way, we then turn around and we need to find the 17th term. So again, no matter which one we use, that means we're plugging 17 in for the n value. Okay? Nothing else really matters here. We're still going to do everything else exactly the same way as we've done in previous problems. We are simply going to evaluate that function when n is 17. And either way, we're going to get the same answer. So here we would have 4 minus 2 times 15, which would be 4 minus 30, which would be -26 if we use our a sub n approach. Well, if we use our initial value approach, that's 8 minus 34, which is also -26. So either way you approach this problem, you should get an expression for a sub n, an equation where you plug in n and get a sub n out, and then you should be able to plug in 17 and you should get -26 as your output from that equation, no matter which version you use.